At last we left off, we had arrived at Euler's equation e to the I theta is equal to cosine theta plus I sine of theta. We just showed one particular scenario where if you let theta equal pi, you get quite an amazing output, quite an amazing identity. But where we want to be is we're going to be working with Euler's equation to get to this general solution of these types of differential equations. So let's kind of work our way backwards, right? Because we defined a lot of things so that we could use substitution to make our derivation a lot easier, but we have to start working backwards a little bit. Now, I took my time. Well, it really didn't take a whole lot of time, but I took a little bit of time to get you to Euler's equation. But I'm going to move a little bit faster to get to the general solution, which was the point of this whole this whole lecture. So, we go ahead and start with the fact that we had defined theta to be equal to beta t. Let's go ahead and plug that back in. So this would be e to the power of I beta t is going to be equal to cosine of beta t plus I sine of beta t. Okay, so the next thing that if you have to recall is all of that work was to focus on how to interpret this e to the I beta t, right? Or beta it, however you'd like to write it. We knew that this was going to be a constant attached. We were trying to figure out how do we interpret this imaginary unit in these general solutions. So what you can imagine is going to happen now is we're going to take this cosine beta t plus I sine beta t and plug it in for this e to the I beta t. Okay, so now let's write what's left at that point. So here's our e to the alpha t, but instead of, now we're going to rewrite e to the I beta t as cosine of beta t plus I sine of beta t. Okay, so now let's get back to where we were all along. So remember these general solutions were y of t is equal to c sub 1, and I'm going to go ahead and write it as, well, remember it's e to the alpha plus I beta t plus c sub 2 e to the alpha minus I beta. Sorry, that's getting a little bit messy. Minus, that's alpha I beta t. And now, let me get to the result. So this last step is we would take this e to the alpha I beta t, e to the plus I beta 2, e to the alpha minus I beta t, write it in the following form, and then you would be just like we were able to substitute here, using that well, let me go ahead and write. gets us to our result that we've been looking for all along. A little bit messy. It gets, I'm not gonna, I mean, I had to go through it, but it's a little bit messy to get to where we are to what I'm about to write next, but more or less just algebraically messy. There is a derivative in there, but algebraically it's a little bit messy, but it's nothing beyond what skill-wise what you have done before. So here it is. Here's what's going to help you answer the questions from this section. So actually, I'm going to park this since I'm writing the general solution. We may as well write it on the next page because we're going to need it. Ready? So the general solution, and this is long, so let me see if I can write it small enough. So y of t is equal to c sub 1 e to the alpha t times cosine of beta t plus I sine beta t. All right, here we go. I don't think I can fit it in here, but plus c sub 2 e to the alpha t times cosine to make sure I got everything in the right spots here. So, yep. So cosine of beta t, now it's minus I sine of beta t. So there it is. That is the general solution for these second order differential equations where your discriminant takes on the form of a negative number so that you end up with complex zeros, complex roots. And let me just, before I go any farther, I want to make sure that since that's a long equation, I want to make sure I copied everything correctly, labeled everything correctly. Yeah. All right. So now, let's do one example. So it says solve the following differential equation, and this is obviously an initial initial value problem. So we're given a little bit more information aside from just the differential equation. We're also told that y of 0 is 0 and y prime of 0 is 0. Now, your job when you start these problems is going to be to just jump in with your auxiliary equation like you did before. Okay, so if we label, so this would, A in this case would be equal to 1, B would be equal to positive 2, and C would be equal to positive 2. Now we're going to go from here to auxiliary equation. So remember it's AR squared, so that's R squared plus BR, so plus 2R, plus C, so plus 2, is equal to 0. And now you start to see if you can factor it, all right? If you can't factor it, you go to your quadratic formula. So in this case, the quadratic formula would tell us that R is equal to negative B, so negative 2 plus or minus the square root of 4 minus 8 over 2 times A, which is just 2. So right now, I know, I know that 4 minus 8 is going to be a negative number, which tells me I'm going to have imaginary units. So I know that I'm going to the following equation to answer this question. All right. So let me show you the most important step here. The good thing, although it took quite a while to get us to that general solution, it's actually not that bad to use. Are you ready? Let me go ahead and, so let's assume that you're at this step right here. So instantly what you want to do is go ahead and break up this quadratic into two different fractions. So this would be negative 2 over 2 plus or minus I square root of 4. Now all I'm going to do is simplify this a little bit more, and then I'm going to show you what theta is going to be and what beta is going to be, and then you got it. Okay, so in this case, r would be equal to negative 1 plus or minus, and ready, let's go ahead and write this as square root of 4 is 2. So since this is over 2, so square root of 4 is 2, so 2 divided by 2 is 1, so that ends up just being I. Okay, so from here you should be able to look at what I've boxed in, and you should be able to tell me what is alpha as well as what is beta. Okay, so if you look back in your notes, previous parts of the videos, so remember that this is alpha, and then whatever is a beta I. So in this case, alpha is going to be equal to negative 1, and beta is going to be equal to positive 1. Okay. So with that in mind, we can jump in to our general solution. So on this page right here, or on the next page, I'm going to go ahead and write the general solution. What am I doing? I'm just plugging in negative 1 for alpha and 1 for beta. Okay, so it looks like this. So the general solution, I'm going to make this a little bit smaller so I can get it all on here in one line. All right, so here's the general solution. So y of t is equal to c sub 1 e. So this would just be equal to e to the negative t multiplied by cosine of t plus I sine of t. All right, good. So plus c sub 2 e to the negative t times cosine of t minus I sine of t. All right, so what is the general solution to that example, that second order differential equation? Well, there it is. But now we want to use the fact that y of 0 is equal to 0 and y prime of 0 is equal to 2. We want to use these two facts to go from a general solution to a particular solution. So we'll start with y of 0 is equal to 0. So what's going to happen right now is I'm plugging 0 in for t, and I'm setting the equation equal to 0. So that ends up being 0 is equal to c sub 1. Now, this is going to end up being e to the negative 0, so it's just 1. So times cosine of 0 is 1 sine of 0 is 0. So that's just going to be 1 plus 0. All right. And then c sub 2. Again, e to the power of negative 0 is just e to the power of 0, which is 1. So c sub 2 times, again, cosine of 0 is 1, and sine of 0 is 0, so this is 1 minus 0. Okay, so we end up with 0 is equal to c sub 1 plus c sub 2. So we'll go ahead and box that in, and we'll need that in just a little bit. So now the y prime of 0 is equal to 2. You can already imagine that that's a little bit messy, because you either but if you listen to this piece of advice, this will save you some time. You can go through and take the derivative of this and then plug in this information. But you also can plug 0 in for t and then take the derivative. Right? So we're not going to lose anything by doing so. You know how to take a derivative and you know how to substitute. Okay, so I got to get us to the answer. So I'll at least do this for you. Y prime of 0 would have been negative c sub 1 plus c sub 1 I minus c sub 2 minus c sub 2i. Okay, so what we're going to do is factor out the c sub 1. As notice, I've kind of grouped them. I'm going to set it equal to we got to set it equal to 2. So we end up with 2 is equal to negative 1 plus I times c sub 1 plus, again, now let's factor out a c sub 2. So this would be negative 1 minus I times c sub 2. And let's box this in as well. All right. So at this stage, we have our system. And let's go ahead and solve our system to get to our answer. Almost done. So c sub 1 plus c sub 2 is equal to 0. Negative 1 plus I c sub 1 plus negative 1 minus I c sub 2 is equal. Now it's equal to 2. So there's your system. Solve your system, you end up with c sub 1 is equal to negative I, and c sub 2 is equal to positive I. All right, so what's the solution? Well, I'm gonna grab this general solution. So that was the general solution. You were missing the values of c sub 1 and the values of c sub 2. But now you have them. So you're done. That is the particular solution. If you were to look this up in the back of the book, it would have the particular solution written like this. And they didn't do anything magical. If you start to distribute that out, what you'll find is quite a lot of things will cancel. And you'll get some I squareds, which will end up equaling negative 1. And so this is the solution that you would see in the back of a textbook. But after you've plugged in negative 1 for C sub 1 and I'm sorry, negative I for C sub 1 and I for C sub 2. Once you're at this step, I'm good. But this is the condensed solution. All right, guys, take care. See you soon.